Assalamualaikum and good day. We meet again in our this is the third class for EEE320 microprocessor 2, where we are focusing in ARM processor. In the first half of the course, while you are going to study about PDA in the second half. Okay, so in this topic, we are going to discuss regarding the instruction set. Why we need to understand the instruction set, even though some of the nowadays most of the embedded system design, the programmer normally use the high level language, but in certain aspect, still assembly language being used. Means that not all the situation can be done by the high level language. Since high level language, for example, C or some other kind of language, they cannot access directly the architecture, the register of the processor. So that's why the assembly language is much more preferred in certain aspect where you really need to have a good, precise assembly, precise application, real-time application is good to, we can have the possibility to use the assembly language. But in our case, since we are the engineers, okay, because for high-level language, you can use to any processor, not dedicated for a particular processor. Have the code and the program, then you can code for any kind of processor. But assembly language is dedicated for a particular processor, cannot be used by other processor, since it will access specifically to a particular register inside the processor. Okay. Okay, before we start, we have to know about the features of the ARM instruction set. Okay, as you know that all the instruction in ARM are 32-bit longs, only 32-bit longs, where most at our stage we can consider all the instructions are executed in a single cycle. Means that you can complete execution of the instruction in the ARM processor within one single cycle. And every instruction can be conditionally executed. Okay, we are going to look into detail later on what we mean by that. We can set actually. Okay, we can set either we can make the instruction to be conditionally executed. Okay, and it is a load store architecture. What we mean by load store architecture, the data processing instruction set only on register. What is it means? It refers to load and store. It means that you, when you execute the instruction, you only execute instruction within the register. You are not accessing the memory. Like other kind of processor, for example, Intel, you can add a number in the memory and a number in the register. You can multiply a number in the memory and you can multiply a number in register. but not in the ARM processor. Everything need to be done between the register. If you are going to uh, get the number from the memory, then you need to get it first and put in the register. Then you can do the operation. You can process the operation. Okay, there will be a three operand format. You can have two or three actually. Combine the LAU, ALU, and shifter for the high-speed bit manipulation. Okay, we are going to look into details of this. Okay, this is because of the 32-bit long. So you are limited. If you want to put a constant value, how can you put within the instruction? If you want to add, you need to have an operand of add, the register, and then also you need to put a constant value. Okay, so that's why you need a, a, what we call, we are going to use the shifter in order to manipulate later. A specified memory access instruction with powerful auto-indexing addressing mode. Actually, there will be you can use either 32 or 8 bit data types. If let's say you are using 32, the arrangement of the address is 8 bit. That is fixed. Okay, but you can use 32 bit. So it means that after the next 8 bit will be the other location. So in 32 bit means that there will be a 4 location of address. And also it can also use the 16 bit data type. Okay, this is for the version 4. Okay, the other features that include in this ARM processor is the flexible multiple register load and store instruction. Okay, we are going to go into detail later on. Instruction set extension via coprocessor. Okay, this part we are not going to discuss. Okay, this is more advanced part. Okay, next processor mode. Okay. Uh, okay. There are only 6 operating modes for the ARM processor. Okay, we have a user, it is an unprivileged mode under which most tasks is run. And then we have FIQ, fake, when it enter the high priority fast interrupt is raised. This is the interrupt mode. IRQ, enter when a low priority or a normal interrupt is raised. Then we have supervisor, it enter on reset. When you push the reset button, it is a supervisor mode. When a software interrupt instruction is executed, it will go to the supervisor mode. So supervisor will take over the processor. Abort, used to handle memory access violation. Okay, you have a fault, normally fault, you will go into under the above modes. Then we have undefined, where it used to undefined instruction. Have fault instruction also, it will use to undefined modes. And in the later version 4, it has a 7 mode. Okay. Add another one mode we will call a system mode. Privilege mode using the same register as user. For your information, actually, we are going to okay register. Why we need register? Why I'm only use register in the instruction set? Okay, that's why we call it as load and store. Okay, you cannot instruction did not access the memory. Everything is done inside the register. And as you know, there are 1,000 registers inside the processor. But there are limited registers which only can be accessed by the user. Okay, so these are the registers that can be used by the programmer. Where I actually have 37 registers in total, where all the registers are 32-bit long. All of the registers are 32-bit long. Okay, one is dedicated for the program counter. One is dedicated to current program status register. 5 dedicated to save program status register for each mode operating. And we have 30 general purpose register. And these are the register which we can handle, we can control it, we can program it. However, these are arranged into several banks with accessible bank governed by the processor mode. Depends on what kind of mode currently being executed by the processor. So, there will be the first one, a particular set of registers R0 until R12. So, a total of 13 registers. R0 until R12, so it will be 13 registers. This is the scratch pad. Or the one that you can use it, you can manipulate, you can put the data, you can gain it, you can do anything with it. Okay, this is a scratch pad. And then we have R13, which is a stack pointer. I think in the previous course we have learned about stack, why the stack is important in every processor. Okay. So normally we don't, even though we can put a number there, we can adjust, we can do a lot of things with it. This all registered, but some of it is being used by the operating modes. Okay, you don't bother about it. Okay, so R13 is a stack pointer, and then we have R14, which is a link register. A link register, actually, we are going to change the mode. Okay, we are going to look later on. Okay, and then we have R15, the program counter. The program counter is the address, okay, contained of the program counter. Whatever inside the program counter is the address of the next instruction to be executed. Okay. And then we have CPSR, the current program status register. These are all the registers which can be used by the programmer. As you know that register, why ARM processor is much more faster, because register is the most fixable that can be accessed by the processor. If you compare to other kind of memory, register is considered also one kind of memory that it is really fast to be accessed. And a privileged mode can also be accessed. It is a particular SPSR, Safe Program Status Register, okay, for each of the operating mode. Okay. Now we look at the organization of the register. Okay, we have the user 32 system, FIQ 32 supervised, user 32 abort 32 IRQ and undefined. And each of it have their status program register. If you look, later on we are going to discuss into detail. Okay? For example, the user mode is R0 until R12. So it is in total 13. While R0 until R7 is the one the same with the system, but the rest is I mean in their own mode. If you change to this mode, it is their own. But RO until R7 is the one that being shared to all of the rest of the mode. And the only that being specific to particular mode is in the shaded block. For example, in supervisor 32 R 13 supervisor. This is only in this mode be available. Next, okay, we have a example register application when we change from user to FIQ mode. Okay, when uh, before we are using the user mode, suddenly there will be the interrupt. When interrupt occur, you see that R15 is the program counter. Okay, return the calculated from the user mode PC value and store that in the FIQ LR. Whatever current address being executed, current address. The next one, it will put inside the R14. R14 actually the link register inside the FIQ mode. And FIQ mode, they have their own register. R8 until R14, they have their own register. Okay. Then it will okay, also the CPSR user mode CPSR is copied to the FIQ mode SPSR. Okay. We will return to the SPSR FIQ mode. When later on you change back from the FIQ to user mode, it will return back to the CPSR. Okay, so this is the example how we change between mode and how the register is used between mode. So these are all the register being used inside FIQ mode. Okay, assessing register using ARM register using ARM instruction. Okay, this slide we are going to discuss it in the next session.